Dimensional analysis is a problem-solving technique oftentimes used in the quantitative analysis of data. What we're going to do here is take a look at this problem-solving technique by doing some metric conversions that we should be a little bit comfortable with so that we can have kind of an idea of how this works. So the first one we have here is converting from milliliters to liters. Now there's the whole move the decimal place over, the King Henry decked his mom mnemonic that we might have used to figure that out. So we're going to use a different technique, this dimensional analysis. And how we're going to start this out is by putting the number that we're trying to convert with units over 1. And the idea here is going to be to change the units using a conversion factor. Now, mathematical properties, we can divide anything by 1. It doesn't change the value of the number. The other thing we can do is we can multiply any factor or any number by 1, and it won't change the value of it. So what we're going to do is we're going to put milliliters on the bottom here so that we're going to be able to cancel that unit out. Much the same way in algebra you might cancel out an x that were on the top as well as the bottom. And then we want to convert to liters, so I'm going to put liters on the top. And now I need to figure out what the relationship between milliliters and liters so that that ratio of liters to milliliters is equal to 1. And again, we can multiply any number by 1 and not change the value. But in this case, we're going to change the unit on it, as well as the magnitude. So 1 liter, milli means 1,000. So it's 1 liter is 1,000 milliliters. So you do want to make sure you get down those basic metric prefixes and their meaning. And then all we would do is get out a calculator and do the calculation, and we would get 0.245 liters. So this part right here, that 1 liter over 1,000 milliliters, is a conversion factor. It's like a tool that we're going to use to change from milliliters to liters. Notice that we can use that same tool in the next one. Here we're starting with 1.8 liters. And so here our conversion factor will have liters on the bottom and milliliters on the top. So 1 liter, 1,000 milliliters. Again, my liters cancel out, and I end up with 1,800 liters. So in the next example, we're converting 5 kilometers to centimeters. So we're going to start with 5 kilometers over 1. And so I know that I'm going to put kilometers here on the bottom so that it cancels out. Here we have a little bit more of a trickier situation because we're going to centimeters. We're not going to the base unit of meters. I don't particularly know how many centimeters there are in a kilometer offhand, but I do know kilometer means 1,000 in terms of meters, and then from meters I can go to centimeters. So I would do this in 2 steps. I would go from kilometers to meters, because I know the relationship between those two, and then from meters to centimeters, because I know the relationship between those two. And so once I set up the path that I'm going to take, and so I can visualize that path, then I can go ahead and put in the numbers and do my calculations. So there's 1,000 meters in 1 kilometer, and 1 meter is 100 centimeters. Centi means 100, like 100 cents in a dollar. And so that would give us 500,000 centimeters for an answer there. So this demonstrates kind of the basic principle of the dimensional analysis. Next, we're going to look at a couple of unique applications of this that could potentially present some difficulties. The bottom line is that you just need to kind of have some faith in this problem-solving technique, try it out, practice problems with it, and once you start to develop a knack for using this method, you're going to find out that it's very efficient in solving problems. So in this problem, we're converting cubic units. So again, if I start off with my basic premise that I'm going to put the number I'm trying to convert or work with over 1, and going from centimeters to meters. So this works very similar again to your algebra. If I do centimeters and centimeters and centimeters, on the bottom I would have centimeters cubed, which would then cancel out with my centimeters that I started with, and do meters, meters, meters. 1 meter is 100 centimeters. And so this would give me an answer of 0.0019 meters cubed. Now, to make our use of space a little bit more efficient, once we see that we had to do the same thing 3 times, we could just cube the one conversion factor. So we could shorten this by doing 1,900 centimeters cubed over 1 times centimeters, meters, 1 meter, 100 centimeters, and then we could cube both the top and the bottom. The thing we have to make sure of is that we cube both the unit and the number. So that 100 part on the bottom has to get multiplied 3 times. And again, we would end up with the same answer there. The other application we have of this is with converting units on both the top and the bottom. So here's a nice little conversion. If we're, suppose we're in a car traveling at 25 miles per hour, and we want to know how many kilometers per second that would be equal to. So here we have units in both the numerator as well as the denominator. So 25 miles per hour. So the hour part is in the denominator. I suppose the hour part would be easiest to start with the conversion. So we can go hours. Now I want to go to seconds. Don't know how many hours or seconds are in an hour, but I can go from hours to minutes, and then I can go from minutes to seconds. So then my hours would cancel out, my minutes would cancel out, I'd be left with seconds for my unit. So 1 hour is 60 minutes, and 1 minute is 60 seconds. All right, so that takes care of the hours in the denominator. What about the miles in the numerator? Well, we're going to do miles on the bottom there. And then it's a matter of, do you know the conversion to kilometers? Having run road races before, I know that there are a 10-kilometer race is 6.3 miles. Or excuse me, 6.2 miles. So I can do a 10-kilometer is 6.2 miles. And then I have my miles canceling out. And so I can figure out my answer in kilometers per second. And so the answer I got was 0.011 kilometers per second. Doing the math on this is not totally a trivial thing. You do have to be a little careful about all this. The way that I usually do it on the calculator is I'll take all the numbers on the top and multiply them together. So 25 times 1 times 1 times 10. And then I'll divide by each of the ones on the bottom. So divided by 60, divided by 60, divided by 6.2. And that would give you your answer there. But again, it's another thing you just need to practice a little bit. So here are the different ways that we see the dimensional analysis. We'll do a lot of practice with this. Again, it's worth spending the time learning how to do this well, as it will make a lot of the analysis and calculations that we do in chemistry much easier.